Okay, welcome back, students. Just want to point out an error in the new Casio CW that you might need to be aware of. Higher level maths, physics, and even at ordinary level maths. So let's put in the speed of light. Let's just see how do we represent the speed of light. So it's 2.99792, etc. We know it to far more figures than that, but let's just settle for that. Times 10 to the 8. Okay, and the exact same thing you would be doing here, 2.99792 times 10 to the 8. Okay, so both of them are keyed in correctly. However, there's a major difference between these two numbers. This is considered to be the product of two numbers, which it is not. It is a single scientific number, and it always has been. But this is treating it differently, which doesn't make any difference right now as I execute. However, when you reciprocate it, the priority of operations is going to come into effect and make it have a drastic difference. Let's work out the wavelength of 1,000 hertz radio wave. So the calculation for that is quite simple. It will be the speed of the light. No, it won't. Will it? It'll be the 1,000 divided by the speed of light. Now, this is where things really go wrong if you use the divide by sign. If I was to come back here and use the fraction bar, then I would be kind of forgiving the mistake because it would still be formatted correctly. But so long as you go like this, the number I'm keying in now should be a single number, but it's not. It's not treated as a single number, which is the mistake that Casio have made, and it's a pretty bad mistake if they don't know their priority. Operations priorities, or bird mass and BIMDAS and things like that, you call it. So it's pretty fundamental to make a mistake like this. So the answer we would get here, and it's wrong, would be you'd be hoping that it would tell you the wavelength of a kilohertz radio wave. Okay, well, let's see what we get over here. Okay, so the wavelength of a kilohertz radio wave is a millimeter. Yeah, it is. C is equal to F lambda. Lambda equals, I have them upside down. But okay, forget about the calculation I'm trying to do. I might be a bit rusty on my physics, but the point is, this is the correct calculation, because it will make absolutely no difference if I put brackets on this, because it's one number and it's being treated as one number. However, you'll see that it'll make a huge difference here. It'll jump from 10 to the 10 back to 10 to the next 6 if I put brackets on this. I shouldn't need to put brackets on a single number, but it's treating it as two numbers. So I hope you catch my drift. It's not trivial, and it could lead to all sorts of issues. It would lead to students making, if they don't know about it, making calculations in exams that are supposed to be correct and marked as correct, but the calculations will set them astray. So now it's corrected itself, but only now. So there's the problem. Scientific notation inputs using the 10 to the x button times 10 to the x is supposed to treat what's called this coefficient times the scaling factor as one number, but it doesn't. It treats it as two numbers. See you in the next one.